Today's lesson is section 6.1, angles of polygons. So we are going to look at how you find the sum of the measures of interior angles and exterior angles. And then we're also going to use that more algebraically in finding the measure of each angle. First, we need to find or define what a diagonal is. So it's a segment that connects any two non-consecutive vertices. All right, so it connects any two non-consecutive vertices. So consecutive vertices are ones that would be side by side. Interior angle sum. So to find the sum of the measures of interior angles of a polygon with n number of sides, so any number of sides, we're going to use this formula. S for the sum equals 180 times n minus 2. Now, in order to keep this video shorter, I'm not going to go into explaining that. Just know it has to do with a triangle and how many triangles you can fit inside your polygon. I would encourage you to look that up maybe on YouTube or Google because it actually is pretty cool. It's like how many triangles can you fit inside of a polygon. All right, so our first example, it says a mall is designed so that 5 walkways meet at a food court that is in the shape of a regular pentagon. Find the sum of the measures of the interior angles of the pentagon. So this formula is to help us find the sum of the interior angles. And guess what? That's exactly what they asked us to find. So let's write down our formula. S equals 180 times n minus 2, where remember, n is the number of sides. So pentagon. So that means our n value is going to be 5. So we do 5 minus 2. And now simplify. So 180 times 3. That means the sum of our interior angles of a pentagon is 540 degrees. Pause the video, take a moment, and try the next your turn. Sorry, I don't know if you can hear my cat purring or not. But the decorative window in the shape of an octagon happens to be 1080 degrees of all of the angles. All right, second example, because that's really easy just substituting in the number of sides. So the measure of an interior angle of a regular polygon is 135. So one interior angle is 135. We have to find the number of sides now. So that means we have to find n. But we need to remember, I'm going to go ahead and write my formula off to the side so we can see it. S is equal to the sum. So if they told me the sum and asked me to find the number of sides, I could just substitute that in for S and we would be 100% finished. But they didn't. But we do know that each angle is 135 degrees. And if I take that times the number of sides, that would give me the sum. So we're going to substitute 135n in for S, and that's going to equal 180 times n minus 2. And now all we have to do is solve this for n. So I get 135n equals 180n minus 360. I'm going to move my 360 to the left so that it's positive. I'm going to move the 135 to the right, so 180 minus 135 is 45n. And then if I divide both sides by 45, I get n equals 8. So that means this is an octagon. All right, try the second your turn. All right, so for this your turn, you should have gotten n is equal to 10, so it would be 10-sided figure. I also encourage you to look back towards I think it was the very first chapter. We went over polygons if you forget what they are. We also went over some of the names of the different shapes, but you may also look that up as well. All right, moving right along. Example 3, find the measure of each interior angle. Okay, so each interior angle. Now, I don't know if you know this or not, but a quadrilateral adds up to 360 degrees. But if you don't know that, we are going to go ahead and figure that out. So, in order to find this, because if they want each interior angle, I could say, all right, I can add 11x plus 4 plus 5x plus 11x plus 4 plus 5x and set that equal to whatever the sum is, and then solve for x, and then substitute it back in. But we need to figure that out first. So to figure that out, we would do our s equals 180 times n minus 2. So s is 180 times 4 minus 2. So 180 times 2, that's how we actually get our 360. But you guys will be doing that so often that you'll remember it eventually. All right, so I can add all of the angles up and set them equal to 360, just as we did with the triangles, but I'm going to shorten it a little bit. So I have two angles that are 5x plus two angles that are 11x plus 4, and that's going to equal 360. So I'm going to get 10x plus 22x plus 8 equals 360. And we get 32x plus 8 equals 360. Subtract 8 from both sides. So 32x is equal to 352. And then x is going to equal 11. So let's reread the question. Find the measure of each interior angle. So we found x, but they want the measure of each angle. So measure of angle R, measure of angle S, measure of angle T, measure of angle U. So now we just have to substitute 11 into each of these. So R and T are going to be the easiest because they're 55. 11 times 5 is 55. Now we have to do 11 times 11, which is 121, plus 4 is 125. Okay, so there's our answer. All right, take a moment, try the next, your turn. All right, so for the your turn, they didn't ask us to find the measure of each angle, so all we had to do was find x, and we found that x is 15 for this trapezoid. All right, the last thing we have to do today is the exterior angle sum. Now, this is one of those things you need to consciously try to remember because it is so easy that you will forget. So it says, if a polygon is convex, okay, meaning that nothing, if we extend each side, nothing is on the interior, then the sum of the measures of the exterior angles which we have 1 at each vertex, so they have them all numbered there. If we add all of those up, it's going to be 360 degrees. No matter what the shape, no matter how many sides, the sum of the exterior angles is always 360. So for number 4, find the measures of an exterior angle. So they want an exterior angle and an interior angle of a convex regular nonagon. So we have to remember a nonagon has 9 sides. All right, so this is actually going to be probably a little bit easier than you think. I don't know why that keeps moving up. So we know that the sum of the exterior angles is 360. So I could take 360 divided by 9, because there's 9 sides, and that's going to give me 40 degrees for each exterior angle. Super easy, huh? And if you notice here, let me erase some of my lines. Let me pick, we'll pick a bright color. If I know my exterior angle, that angle and my interior angle create a straight line. And we all know that a straight line is 180 degrees. So to find my interior angle, now that we already know the exterior angle, we can take 180 minus 40, and that's going to give us our exterior angle. Or, I'm sorry, my interior angle. So my interior angle is 140 degrees. So remember, your interior angle and your exterior angle should always add up to 180 degrees. Let's take a moment, try the last one. All right, so for the last one, you should have got the exterior angle to be 60 degrees and the interior angle to be 120 degrees.